start off with a normal chessboard and one king. In 0 moves, the king can only reach its current square, so let's highlight that in red. I'll now highlight the squares the king can reach in at most 1 move. Nothing special so far. Now let's look at 2 moves, 3 moves, and so on. We're running out of space, so let's zoom out and forget we were playing chess. Well, the shape we get is a square. This is where the famous chess endgame rule, the rule of the square, comes from. Now let's add another king. And because we abolished the idea of actually playing chess, this king moves like a rook, but only 1 step at a time. Let's take a look. Let's zoom out again. The shape here is clearly a diamond or a rhombus, so a square tilted to its side. For our final king, I couldn't come up with any fancy chess rules, so let's just see what it does. Well, that's clearly a circle. Now let's see which king is the fastest. I've put them on a line, and we'll highlight the squares they reached first with their respective colors. In case of a tie, there's no highlight. Ready, get set, go! Oh boy, looks like the red king is just dominating. Let's do that again, but more zoomed out. Let's have a look at what happens when all 3 of them move like the red king. Well, nothing much. That was pretty boring. Let's try to do the same thing but with blue. Well, that's boring. And with green, pretty much the same thing. To make it more interesting, let's change the starting positions and do the 4 races again. The patterns created here are called voronoi patterns. Depending on the metric used, the way the king can move, the pattern changes. The red king corresponds with the Chebyshev metric. Here's how it looks like for more points and on an infinite resolution level. The blue king uses the Manhattan metric, and the green king uses the Euclidean metric, or the distance that we use in our everyday lives.